Okay, ladies and gentlemen of algebra, this is Unit 7, Note 7, talking about probability with combinations and permutations. So what you need to be able to do is solve probability problems involving combinations and permutations. So take a look to remember what is going on here. You have combinations and you have permutations. And in combinations, order does not matter. You got to think, if it matters, does it matter if I get picked first or last? Do I still get picked? Yes, that does not matter. Then it's a combination. If order does matter, if the first person that gets picked is somehow different than the last person that gets picked, then it is a permutation. So a combination bike lock requires a 3-digit code made up of the digits 0 to 9. No number can be used more than once. Figure out what it is. Okay, so we look. How many different combinations are possible? What is probably that all the digits of the code are odd? Well, let's take a look at this. How many different combinations are possible? Well, you cannot use the same one more than once. So that means order is going to matter because once I pick like 7, or once 7 gets picked, I can't pick 7 again. So this is going to be 9p3. All right, so 9 P3 is going to be 504. So there's 504 different combinations. So what's the probability that all the digits of the code are odd? So from 0 to 9, 1, 3, 5, 7, 9, 5 odd numbers. So what this is saying is like saying out of the 5 odd numbers, choose your 3 out of that. And then that's going to be out of 504. Okay, this is that 9p3 part that we were talking about before. So 5 choose 3 is going to be 60. So that probability is going to be 60 out of 504, which is simplifies to 5 over 42. So what is the probability that the first digit is 3? Well, so now here's where you get a little bit trickier, okay? Because the first digit is 3. So let's change our thinking here a little bit. First digit is 3, so I have 3 digits. So the first digit has to be a 3, so that's 1. I have 1 chance for that one. So now, after that, I've still got 2 chances, and I've still got 8 numbers left. So that's like 8 times 7. Okay, this is another way of saying like the first one is 1. The first one can only be one number, that 3. Then after that, it's like 8p2. Okay, so the first one's already dominated by that, and that's all going to be over 9p3. And the reason for that is because you're taking away that first digit. That first digit has got to be a 3. That means there's only one possibility for that, and that is going to be 3. After that, then I've got possibilities. Okay, so what this ends up becoming is 56 over 504, which simplifies to 1/9. So 1 out of 9 chance that you're going to do that. So now, what is the probability that the code is 1, 2, 3? Well, how many codes are 1, 2, 3? 1. 1, 2, 3. Okay, that's going to be 1 out of 504. So a word processing computer program requires the user to enter a 7-digit registration code made up of the digits 1, 2, 4, 5, 6, 7, and 9. Each number has to be used, and no number can be used more than once. So what you've got is 7 numbers, and you've got to enter that code in 7 different ways. So what this is basically saying as a permutation, it's like saying, not 9, not 9, there's only 7. It's like saying 7p7, which is kind of a fancy way of just saying 7 factorial. Boop. So it's 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5,040. So there's 5,040 ways to do that. What's the probability that the first 3 digits of the code are even? Okay, so how many even numbers do I have? I have 2, 4, and 6. So here's kind of the way I like to think about it. How many different ways are there to get the 3 first codes even? So you got to break it up. Here's how I like to break it up. The first 3 got to be one way. The last 4 are obviously going to be odd. Okay, so here's kind of how this works. This kind of becomes like 3 times 2 times 1. And here's why. For the first 3, they have to be even. I've got 3 even numbers to choose from. So for that first spot, I've got 3 even numbers I can put in there. For the second spot, I've already chosen one of the even numbers to go in the first spot. So for that second spot, I've got 2 left. Say I put 2 in the first spot. That means I've got 4 and 6 for the second spot. And that means I've only got 1 even number left for the third spot. So this is a little like saying 3p3. Then over here, I've got 4 odds left. So 4, 3, 2, 1. It's like saying 4p4. So 3p3 is going to be 6, and 4p4 is going to be 24, and that's going to be out of 5,040. So 6 times 24 is 144 divided by 540. So there's 1 out of 35. Sorry, that's a 5, not an 8. So 1 out of 35 would be my answer for that. All right, so next one. What is the probability that the first digit is a 1? So out of all of my possibilities, that first digit has got to be a 1. Okay, so that means for that first digit, I've got one choice. It's like saying 1p1 for that first one. Then after that, I still have 6 other spots for the other 6 numbers. So 1, 2, 3, 4, 5, 6. So this is kind of like saying for the other one, 6p6. Since it's a probability, it's all going to be over 7p7, which is at 5,040. So 1p1 is just 1, okay? 6p6 is like saying 6 factorial, and that's going to be 720 over 5,040. So 720 divided by 5,040, that's going to be 1/7. So what's the probability that the code is 1, 2, 4, 5, 6, 7, 9? So what's the probability that is that exact order? Well, there's only one of those out of 5,040 ways. So there's your probabilities. So a group of 7 seniors, 5 juniors, 4 sophomores have volunteered to be peer tutors. Mr. Domingos needs to choose 12 students out of the group. So you need to pick 12. It doesn't matter if you get picked first or 12th, you're still a tutor. So how many different ways can we do that? So let's take a look. How many different ways can the 12 students be chosen? So you've got 7, 5, 4. So 7 and 5 is 12, another 4 is 16. This is going to be 16 choose 12. Okay, 16 C12 there. So that's going to be, hold on 1 second. So that's going to be 1820. So there's 1,820 ways to do this. So what's probably that he chooses 4 seniors, 4 juniors, and 4 sophomores. Okay, so here's where things get a little bit trickier. All right, so he's got to choose 4 seniors. Doesn't matter if he gets picked first or last. You're still choosing a senior to be one. Then you got to pick 4 juniors and 4 sophomores. Well, here's kind of how that works. Each one is another little mini combination within a bigger scope of the problem. And here's what I mean that. All right, so out of 7 seniors, he's got to pick 4. So that's like saying 7C4. That takes care of the seniors. Out of the juniors, he's got 5 juniors, and he's got to choose 4. Out of the sophomores, he's got 4, and he's got to choose all 4 of them. All of that's going to be over the 16 choose 12. Okay, so give me a second to calculate that. So 7 choose 4 is going to be 35. 5 choose 4 is going to be 5. 4 choose 4 is going to be 1. So I end up with 35 times 5 times 1, which is 175 over 1820, which is going to be 5 out of 52. There's your probability right there. What's the probability that all 7 seniors are chosen? So here's kind of the situation. Out of the 12 students, out of the 12 peer tutors, 7 of them got to be all 7 seniors. So that means out of 7 seniors, I've got to choose all 7 seniors. Now after that, I've got just what's left. So I've got 5 juniors and 4 sophomores. So that's 9 kids left for 5 other spots. Okay, so this takes care of the seniors, but there's 5 other tutoring spots out of 9 kids, all out of that 1820. So 7C7 is 1. 9C5 is going to be 126. So that's going to be 9 out of 130. All right, Diane has a bag full of coins, 10 pennies, 6 nickels, 4 dimes, 2 quarters, for a total of 22 coins. How many ways can Diane pull 4 coins out of the bag? Doesn't matter if you get picked first or picked fourth. You're still a coin that gets picked. So that's going to be 22C4. So that is going to be 7,315 different possible combinations. It's a lot of different combinations for pulling out 4 coins. So what's the probability she will pull 2 pennies and 2 nickels out of the bag? Well, she's got to pull exactly 2 pennies and exactly 2 nickels. But it doesn't matter which the order they come in. But here's kind of how I represent that. I've got 10 pennies and I need 2 of them. So that's going to be 10 choose 2. I'm going to multiply that by the nickel situation. I've got 6 nickels and I need 2 of them. All that's going to be over my probability of 22 coins and 4 picked. So 22. So 10 choose 2 is going to be 45. 6 choose 2 is going to be 15 out of the 7,315. So 45 times 15 is going to be 135 over 1463. This one you could actually convert to a decimal. It's going to be 0.09. So it'd be about 9%. The next one was probably that she will pull 4 pennies out of the bag. So this one's even a little bit more specific. This one's saying it's got to be all pennies. Well, it doesn't matter what the order of the pennies come out is. It's going to look like this. So it's going to be 10 choose 4 out of 22 choose 4. So that's going to be 210 over 7315. So that's going to be 6 out of 209. All right, so let's erase this first part. Let's get these out of the way. Let's pull up the next one. What's probably she will pull 4 dimes out of the bag? Well, 4 dimes. There's only 4 dimes in the bag. That means I got to go 4 choose 4 over the 22 choose 4. So 4 choose 4 is just 1. So that means the probability of me doing that is going to be 1 out of 7315. Go and do your assignment. Don't worry about the quiz. The quiz doesn't exist, so don't do it. So go do your assignment and come talk to me and take questions. And I will show you how to do it on a calculator if you so wish. Have a good day.